Hello everyone, we are from BOTANIDE, a brand that creates architecture-aligned 3D printed planters. Our mission is simple, is to transfer plants into architectural element. Instead of using generic pots, we help architects and designers integrate planters that truly match their project design language. Next slide, please. During our research, we identify a clear gap in the market. Premium residential and commercial projects increasingly demand customized decorative elements. However, traditional clay and concrete craftsmen have limitations in producing complex geometrics and highly customized forms. As a result, architects often struggle to find planters that fit their uh, design vision. Botanists bridge this gap by providing custom planters specifically designed for architectural projects. Next slide, please. Our primary customer are architecture firms or interior design studios. To validate this market, we already interviewed a couple architecture company like Moose House, Air Studio, Dawn Architects, and also Guba Ruang Studio. From these interviews, we found four key needs. First, unique geometry that in traditional craftsmen cannot produce. Second, design alignment with architectural styles such as tropical, Nordic, brutalist, and other. Third, low maintenance solutions like self-watering system. And fourth, a supplier capable of handling both custom and bulk project orders. Next slide. Botanit addresses these needs through four main value propositions. First is a parametric designs enabled by 3D printing technology. Second is a project-specific customization, allowing every planter to match the project architectural concept. And third, sustainable hybrid biopolymer materials that are lightweight, durable, and also environmentally friendly. And finally, it is a self-watering system that reduces maintenance while keeping plants healthy. Next.
Now we get into our prototype development, and our prototype is currently high fidelity physical prototype, and we make this prototype to test the design demand, feature viability, and price suitability. But there are one major limit for our prototype is due to our due to our 3D printer machine, we can only make small pots or around 30 times 30 centimeter max. And for the evolution of our prototype in this semester is in the early semester, we only strictly form focus or strictly focusing on our design and not adding any feature uh, yet. And in the middle semester, we conduct a deep dive interviews with local architecture studio and adding some features that are uh, necessary and asked by our local architecture studio. And in the last semester, we redesigned the internal structure of our parts or our prototype to fix some of the features. And at the end of the semester, we fine-tune final production dimensions and pricing structures.
Okay, next one is Ganesha Business Fest feedback. At Ganesha Business Fest, the visitors gave us positive feedback and like they like our cute and lightweight design, premium finishing, and unique geometric shape. These points made Botanite stand out from normal plant pots. However, they also had concern. The production time was too long because we could only print one unit at a time. They want faster ordering processing. They also said that the surface is not smooth enough and the details are not neat. So we improved the product by adding sanding and post-processing. We also changed the business model into a ready-to-print catalog so customer can choose existing design and get faster production. Next.
Now we move into the concept testing and we use the interview method. For the samples, we have Moose House, Air Studio, Dawn Architect, and Gubah Ruang Studio. Samples that provide in-depth knowledge regarding pot buying behavior to premium villa and architecture industry. And for the questions, we ask the problem validations, which design is preferable, are the features actually wanted and necessary, and does the price actually suitable? And we communicate our product by verbal presentation, physical prototype, and 3D rendering model. Now, for the results, the problems are actually exist for our target markets, and the design they prefer the tropical and vernacular style because they have high demands in the market, and adding geometrical pattern to these styles will give the product more value. And the features, some of them are unwanted or necessary, such as self-watering, anti-slip bottom surface, and ambient light, and some of them are actually not necessary, such as humidity sensor. And price suitability, the suitable price is around 150,000 rupiah to 250,000 rupiah. And we get some feedback such as the 3D printing is not actually perceived as cheap, but can be premium based on the design. And for the prototype, some features need to be worked on or fixed, and the color needs to be more flexible for the styles. And for the grow light feature is neutral to skeptical for B2B.
Uh, and then the next one is market potential and go-to-market strategies. For market potential, we use TAM Samsung. The TAM is around 135,000 units per year, worth 74.25 billion rupiah. This includes active design studios in Indonesia. Our TAM is 1,800 studios over Indonesia. Our SAM is more focused, around 100 luxury residential and parametric design studios in Bandung and Bali, worth 4.3 billion rupiah. For the first years, for this year, our realistic sum is 25 studios with estimated sales of 360 units per year or 72 million rupiah. And then our go-to-market strategies is start with a sample kit, then material library, digital catalog, production specification, and finally with bulk orders. Next. We count Here's how we count the market potential or market demand. To calculate the demand, we use Q equal N times A times P. N is 25 studios, A is 60 unit per studios per years. The P is 0.24 based on conservative purchase probability. So with a price of 200,000 rupiah per unit, our estimated revenue is 72 million rupiah in year one. Next.
Now we get into our financial projection. We assume price per unit is 200,000 rupiah. And in the first year, our sales is 360 units, and we project this into 5 years. The sales growth per year is 15%. Now, if you look at our revenue projection, the revenue growth for 5 years is around 74.5%, and each year the growth is around 15% or the CAGR. And the NOPAT projection in the first year is 320,000 rupiah, and in the last year or the fifth year, the NOPAT is 23 million, around 23 million rupiah. Now, another important key takeaways are the payback period for this business is around 4.94 years, and the NPV is minus 22 million, around minus 22 million rupiah, and the ERR or internal rate of return is 1%, and the profitability is 0.59%, or we can round it to 0.6. Now, the final recommendation is for this business is no go. Our several reasons are: first one, destruction of economic value because of negative NPV. Now, previously, we stated that the NPV of our business is minus 22 million. This means that executing this business is destroying the long-term wealth value for the owner. Now, the rate of return is too low. The our IRR is 1%, which is below the VICC, or discount rate is 14.77%. Now, the next reason is liquidity risk and long payback period. Now, for this business, it took 4.94 years just to break even on its initial investment. And given that 3D printer technology is evolving very rapidly and prone to obsolescence within 3 years, holding capital tied up for nearly 5 years on a rapidly depreciating asset poses intolerable operational risk. And our last reason is stunt market scalability. Also, in year 5, the cash accumulation turned positive to around 1.39 million rupiah. This profit value was obtained after 5 years of hard work. This limitation occurs because the B2B architectural market mostly requires only large pots, while our tool production capacity is limited to small pots. Now, thank you for your attention, and these are our appendix.